lecture 29, and this is our problem solving session number 7, and we solve problems on 2-port parameters as a finale to 2-port parameters. 2-port parameters we have already discussed in theory, and we end up this discussion with a few problems of, as I said, non-routine nature. We start with problem number 1. Problem number 1 and the problem is to determine the z and y parameters of the network shown below, which as you see is not a totally RLC network. It has controlled sources, dependent sources, a current generator and a voltage generator with specified polarities. This is 2 ohm and this is V2, this is V1, just to identify the ports. You have to find out the z and y parameters of this network. Okay. One thing that one should be careful about the occurrence of control sources is that if this voltage, for example V1 is killed, okay, for example if you want to find Y22, then V1 this shall be short circuited. If V2 is killed, then this shall also disappear, and therefore it offers simplification. Another thing that one should notice is, in a similar manner, if V2 is short circuited, if port 2 is short circuited, alright, then what will happen to this current generator? It will be opened. Okay, V2 equal to 0, so the current is 0, current generator internal impedance is infinity, and therefore this will be open. Alright. The other thing that one should be careful is whether the network is reciprocal or not, because the occurrence of control sources has the potential of making the network non-reciprocal, and therefore you should not only calculate Z12 and say Z12 equal to Z21 as you do with reciprocal networks or networks composed of bilateral elements. Control sources we can't say. If control sources occur, it is not necessary that the network is non-reciprocal, alright, but if control sources occur, there is a possibility that the network may be non-reciprocal. In other words, all the 4 parameters have to be computed, not 3, alright. Okay. Now let us see, let us calculate Z11 and Z21. For both of them, the definition says V2 equal to 0 and Z11 is equal to V1 by I1, pardon me, I2 equal to 0, that is correct, thank you. V1 by I1, I2 equal to 0, and Z21 is equal to V2 by I1 with I2 equal to 0. So let us keep I2 equal to 0, and therefore these terminals are left open, and we have to find out this current I1, and this voltage V2, alright. Then we will be able to find out both these parameters. Okay. One thing that we notice is that if this voltage, now let me use a different color, if this voltage is V1, then this voltage is also V1, okay. Now this resistance is 1 ohm, that is given, this resistance is 1 ohm and this resistance is also 1 ohm, okay. I did not put the resistance values earlier. Let us go systematically. This voltage is V1, and what is this voltage? This is V2 V2 minus 2V1, okay, V2 minus 2V1, alright. This is V2, then there is a drop to V1, so this voltage is V2 minus 2V1 with the same polarity, plus minus. Therefore the current through 1 ohm, this current shall be equal to this voltage minus this voltage divided by 1, agreed. So V1 minus V2 plus 2V1, in other words it is 3V1 minus V2, agreed, and that solves the problem. Once you are able to identify this current, you see my equation shall be I1 if I write KCL at this point, I1 at this point, okay, I1 is equal to V1 by 1, that is this current through this resistance, then 2 V2 is coming, so minus 2 V2, then 3 V1 minus V2 is going, so 3 V1 minus V2. If you simplify this, it is simply 4 V1 minus 3 V2. Agreed? This is equal to I1. We also notice well, this kind of a simple minded approach requires experience, requires practice. But you also notice that this current 3 V1 minus V2 must be the same as this current, that is V2 by 2. Agreed? V2 by 2, it is the same current as this. Therefore, the second equation of our circuit is 3 V1 minus V2 is equal to V2 by 2, or 3 V1 equal to 3 V2 by 2, which makes V2 equal to twice V1. Agreed? V2 equal to twice V1, which means if I combine now with the first equation, I get I1 as equal to 4 V1 minus 3 times V2, 3 times 2 V1, which is equal to minus 2 V1. All right? Is it okay? Have I made a mistake somewhere? No. Therefore, Z11, which is the ratio of V1 to I1, is minus half. Is that okay? I1 is minus 2 V1 and therefore Z11 is minus half. It comes as negative, there is a negative resistance is realized at port number 1, and it happens because of control sources, which means that the circuit is active. Wherever negative resistance occurs, instead of dissipating energy, it generates energy, and therefore the circuit is an active circuit. Number 2, I want to find out Z21, which is equal to V2 by I1. No, it is simply V2 by I1. Yeah, pardon me, what did you say? Minus 1, that is right. Because how do I find this? V2 is 2 V1 and I1 is minus 2 V1. Everything expressed in terms of V1. So, Z21 is equal to minus 1. Now, this does not mean that Z12 should also be equal to minus 1. You have to calculate that. In other words, there is no escape. You have to take the network again and put I1 equal to 0, and the network then becomes 1. This is V1, I1 is 0, no entry of current from port 1. Port 1 is open circuited, then you have a 2 V2 and then 1 ohm, the source minus plus 2 V1, 2, then you have an I2, you have to calculate Z22, so you connect a voltage source here, V2. Okay, and all you have to find out now is I1 is 0, therefore Z22 is equal to V2 by I2, and Z12 is equal to yeah, V1 divided by I2. Oh, it does not matter. I have not shown whether it is a voltage source or current source. It could be current source, it could be voltage source. All that matters is this is V2, this voltage, and the current drawn is I2. That is all. Okay, I have not drawn a well, I have drawn a voltage source. This is the symbol. If I had drawn a current source, I would have shown an arrow, but it does not matter. You simply call this a source. If necessary, you call it you indicate it by a rectangle to indicate that we do not know what this source. We do not care. Not that we do not know. We do not care. Okay. Now, to find I2, let us see what these voltages are. This voltage is V1, this voltage is V1, and this voltage, as we find out earlier, is V2 minus 2V1. Therefore, this current let us take in this direction. Okay. This current would be V2 minus 2V1 minus V1, that means it would be V2 minus 3V1, alright. And then all that you have to do is to write the node equation at this node. I2 would be equal to V2 by 2, it is this current, plus the current that goes via this branch, which is V2 minus 3V1, that is equal to 3V2 by 2 minus 3V1. Agreed? I2 equal to 3V2 by 2 minus 3V1. And then you find out the KCL at this node. Okay, the current through here, current through this branch is V1 by 1, then minus 2V2 because it goes up, and minus this current comes in minus V2 minus 3V1, this must be equal to 0, alright, which says that, let us say, minus 2V1 equal to 3V2. So, no, I have made a mistake. This should be plus, so 4V1, okay, 4V1 equal to 3V2. Therefore, V1 equal to 3V2 divided by 4. Don't allow me to make a mistake. Okay, V1 equal to 3V2 by 4, and therefore, if I substitute this, then I get I2 equal to 3V2 by 2 minus 3V1, that is 9V2 by 4. And I can write this as 6V2 by 4. Therefore, this is equal to minus 3V2 by 4, and therefore Z22 is equal to minus 4 by 3. Alright, this is also negative. Finally, Z12, which is equal to V1, yes, V1 by I2. V1 is 3V2 by 4 and I2 is minus 3V2 by 4. So, this is equal to minus 1. What was Z12? Also minus 1. Therefore, even though Z21, therefore, even though control sources occur, the circuit is reciprocal, but not passive. It is active and reciprocal. All right. Is there another way of working out this problem?
Mass equation.
Pardon me?
Mass equation and invert the mass equation.
What equations?
So we write mesh or loop equations.
Oh, you write mesh or loop equation. Well, that we don't want to do till we are forced to, because that means writing a set of simultaneous equations solving for the current sensor. We don't want. If we can do it by inspection, why not? Okay.
So we can write the node equation for
that
one
is
node and for second node, and then we say that in terms of V1 and V2, that will straight away give the Y parameters.
yes. What we could do is, you see, after all, there are only two nodes. We could connect a voltage source here. We could connect a voltage source here and write node equations here and here. All right. I could write in terms of I1 and I2, could be expressed in terms of V1 and V2. Then we get the Y parameters, okay, and then we could convert them to Z parameters, or, well, no or, that's what we will have to do. Otherwise, you will have to write V1 in terms of I1 and I2. Well, that also can be done. You can apply Thevenin's theorem here, all right, make it into a single loop network. There are many ways that this can be done, but let us do in this simple minded manner, going back to the roots. Please remember, going back to the roots, the chances of making a mistake is reduced considerably. and this problem is not too complicated that we cannot solve it by going back to the roots without any complication. Okay, let's see y11, the y parameters y11, y22, y12 and y21. To find y11 and y21, these two.
Use the transformation formula.
Pardon me?
So directly can we use?
I can use the transformation also. That is one method. All right, that is one method. Well, the transformation means you will have to find the determinant of the matrix, divide the corresponding. Oh, it's not too difficult. Let's do that. Then maybe we will go back to the roots and see. You see, going back to the roots, it becomes much simpler. The y parameters become much simpler. All right. But suppose we say, what was our z11 minus half and z12 minus 1, then minus 4 by 3. Okay, inverse of this. So this is equal to minus 4 by 3, this one, divided by, what is the determinant? 8 by 3 minus 1. Is that right? This multiplied by this? 2 by 3. Okay. 2 by 3 minus 1, which is equal to minus 1/3. Agree? So this divided by minus 1/3, then minus 1 divided by minus 1/3, same comes here. Here I get minus half.
So 1 divided by
It should be 1 divided by. How wonderful. The negative sign goes off. Agreed. And this would be minus half divided by minus 1/3. So the y parameters finally become 4 minus 3 and 3 by 2. Let us see if these agree. If we make the calculations ab initio, that is from the roots. Okay, let us see. For y11 and y21, we have to make V2 equal to 0. And if we do that, the equation, the circuit simply becomes this. We have a source V1 I1, then we have this 1 ohm, we have this 1 ohm, 2 V2, that current generator vanishes because V2 is made equal to 0. Okay, current generator vanishes and therefore I have minus plus 2 V1 and a short circuit, the current through which is I2. All right, this becomes the circuit, and what we have to find out is I1 and I2. I1 and I2. Now, if you write the node equation at this point, I1 is V1 by 1, okay, and what is the voltage across? This is V1. What is the voltage across this? No.
Minus 3 V1.
Is it minus 3 V1 or plus 3? Plus 3 V1, and therefore the current is 3 V1. You must not make a mistake. This is V1 minus plus and this is minus plus, and therefore the drop across this would be V1 minus 2 V1, which is equal to 3 V1. Is the point clear? Suppose the polarity was this and this was plus, this was minus, then I would simply V1 minus 2 V1. But no, it is V1 minus 2 V1. So 4 V1 is equal to I1, which means that Y11 equal to 4. We have already found that out. Okay, and I2 is simply, we have already found this current as 3 V1, so it is minus 3 V1. Therefore Y21 is equal to minus 3. That's what we had found out. And in a similar manner, you can find out Y11 and Y12. Can you skip that rest? Now, if we have found out Z11, Z12, Z21 and Z22, do we still have to calculate Y12? No. you argue that we have already shown that the network is reciprocal, therefore y12 must be equal to -3. All that you have to calculate now is y11, and which is also simplicity itself, because short circuiting the input terminal reduces the voltage source to 0. There is only a current source, alright, and it becomes simpler to take care of the situation. We go to problem 3. Problem 3, we skip one of them, and problem 3 says, yes.
So in the second part to find V2 for this question, for the previous question, so when we remove the voltage source, we put a short circuit across the first port.
That's
Then the resistance is that 1 ohm resistance in parallel with the current source. That is also removed.
That is also removed, yes.
So then the current source simply becomes, all the current will flow through that short circuit.
That is correct. That is
So
correct.
that is also
Alright, let me draw this network. Let me draw this network. It's an interesting question. You see what happens, I am talking of the previous circuit. V1 is made equal to 0. This is the current I1 through the short circuit, okay? 1, then you have 2V2, then you have 1 ohm and 2 and V2. Okay, what his question was, I1, naturally no current shall flow through 1, but this current generator, it cannot be killed. If there is a V2, there shall be a current, 2V2, and therefore the current that enters here is I1 plus 2V2, and that must be equal to the current that flows here, which is minus V2 by,
minus 2 V2.
no, I1 plus 2V2 shall be equal to minus V2, because this point is the same as this point, and therefore this 1 ohm comes across V2, alright, and then I2 shall be equal to this current plus this current. That's how one finds out.
So the thing is, won't that entire 2V2 current flow through the short circuit?
No, no. Well, we don't care where it flows. All we know is at this juncture there is a current I1 coming. This 1 ohm becomes absolutely redundant. 1 ohm cannot carry a current. But at this juncture 2V2 comes and I1 comes. Okay? We don't know. Why not? We don't know whether the total current will flow through this or not. No, we don't know.
But shouldn't it flow through the path of least resistance?
Okay? Shouldn't it flow through the...
So, but there is a current generator, sir.
Huh? There is a generator here.
So that is generator, sir. It's a current generator.
It is a current generator.
So generate currents are independent of the short circuit.
Correct. But his question is, shouldn't I1 be equal to minus 2V2?
So no
Because
difference
there is an
about
addition because of V2.
That's right. There is an additional current going here. These are not the only two currents. There is a third current. And we have taken care of by writing KVL at this particular. KCL, yes. I stand corrected. Question 3. Question 3 has to be done very carefully. Well, each question is to be done carefully, but there is a pothole here which one has to guard against. Question 3 is, we have a network in which 2 ohms comes in parallel with a current IA, and then we have a network N, a 2-port N, and a 1 ohm resistance. Then there is a bridge. There is a bridge half ohm. Okay, this is the composite network. That is, there is a 2-port which is augmented by 2 ohms, 1 ohm here, and a bridge of half ohm, and this is V2. This voltage is V2. This voltage is V1. All right. What is given is that this parameter, the parameters of this network these are given. This network is y11 equal to y22 equal to 2 mhos, y12 equal to y21 equal to 1 mho, and Ia is given as 1 ampere. The question is to find V1 and V2. Okay? This is the question. You understood the question? Now how do you solve it? Let's have suggestions.
Replace this by a pi network.
Can we replace this by a pi network? No. We cannot, because the other network, what you are trying to do is to view this as a parallel connection of two networks, right? Parallel connection, half 2 mhos, 2 ohms, 1 ohm. But it is not given that these two are connected together. So you cannot make a parallel connection, because this could be truly a 4-terminal network. Agreed? This is the temptation, this is the pothole. Fortunately, in this particular case, this also gives correct result. and that is the point of the question. The question is framed such that even if you consider this is a parallel connection of two ports, you get the same result as you get by considering capital N as a truly 4-terminal network. But if you are happy with the answer, the examiner would be unhappy with the answer, because the method of calculation would be wrong, W-R-O-N-G. Alright? Now, therefore, what would be the correct method? Now go back to the roots. Go back to the roots. That is, what you do is the following. Let's identify some currents and voltages. And this is why I said you have to be very careful. I have done it both ways, the wrong way and the right way, and they give the same result. Suppose you were told that this is a short circuit. Then there is absolutely no problem. You just find out the y parameters of this pi network and add to the y parameters of the network N and determine I1 and I2. But no, this cannot be done here because this is not specific. Therefore, we postulate currents I1 and I2. We postulate currents I1 and I2. Alright? And I write at this point the KCL. The KCL would be 1 would be equal to 1 ampere would be equal to V1 by 2 plus I1, okay, V1 by 2 plus I1 plus V1 minus V2 divided by half. Alright, this is one of the equations, and the other equation is at this node. Okay, alright, the simplification of this gives what does it give? 1 equal to V1 by 2 plus I1 plus 2V1 minus 2V2. Therefore, this is equal to 2V1 and V1 by 2. So 5V1 by 2 minus 2V2 plus I1 equals to 0. Equal to 1. Equal to 1. Thank you. The other equation is, if I look at the network, V2 by 1 plus I2 plus V2 minus V1 divided by half, this would be equal to 0. Right? Yeah.
So in writing the first equation, we have already assumed that the negative terminals are at the same potential for V1 and V2 for both the ports.
Yes, because the reference has to be the same.
Yes, we have.
Yes. And sir,
In fact,
there lies no point of now in not making the.
I am glad you discovered it. So what is the way out? You see, writing this equation tacitly assumes, and he has correctly caught me doing this mistake. You see, my V2 reference is not necessarily the same as V1 reference. Alright, and when I say the only problem is here, V1 minus V2 If I do that, then obviously the references have to be the same. Agreed? And therefore this method going back to roots also does not work. Agreed? So what is the way out? What is the way out? Shall I discard it at this point? Are you convinced that it should be discarded?
Yes.
Because doing this simply means that we are assuming that these two are connected together, which is not correct. So what is it that we should do now? What do we do now? Well, that's called a convenient detour. If there is a problem, all right, avoid it. No, we want to counter it, we want to confront it. What is the solution? Can we go to find out the y11, y22, y12 and y21 of this total network?
Yes.
Can I do that?
Yes.
How? For example, if you want to find out y11, I have to short circuit this. Okay, if I short circuit this, then what would be y11?
So then the parameters are
the same problem.
Same problem. In other words, you see, if I short circuit this, let's do it, short circuit this, then my y11 total would be this admittance plus y11 of the network n, okay, half more plus y11n plus I don't know how this half ohm comes into this circuit because I don't know what is connected between these two, and therefore I have the same problem, and I claim that there is no way that
Can
we
we
can
take one more variable?
one more variable. How would you solve it?
equations are there.
The number of equations will be only 2. All that you can connect is V1, I1, V2, I2. That's all. Nothing else. And therefore, this problem is not solvable unless these 2 points are connected. All right? Okay. So now we can leave it. All right? As per suggestion, we can go to the next problem. Next problem is question number 5. It is not that I am leaving only the tough one. No, I am just taking alternate problems. Determine the y parameters of the network. Question number 5 is determine the y parameters of this network. The network is this: R1, V1, and then you have a C1, C3, a control source KV1, and a capacitor C2. If you notice carefully, there is an R2 somewhere. Yes, there is an R2 here. Okay. If you notice carefully, oh, there is a V2 here, port number 2. If you notice carefully, this is simply the equivalent circuit of a BJT or FET, isn't it? R1 is simply R pi, C1 is C pi. Are you acquainted with this terminology? Okay. C3 is C mu and C2 is C0, output capacitance. R2 is R0, that is the collector dynamic resistance, and this source KV1, K is simply GM, and V1 is the voltage across R pi, which of course assumes that Rx is neglected, the base spreading resistance is neglected. Now, to find the y parameters of this network, the easiest thing to do would be to view this as a parallel connection of 2 networks. okay, and you see how the parallel connection is chosen. One of the networks we choose, fortunately there is a straight connection, it is a 3 terminal. So, one of the networks that we choose is R1, let us call this V1A, the A network, and KV1A, that is it. No, let us include R2 also. This is V2A, alright, I1A, I2A. This is my A network, and the B network is simply the capacitive network, that is the B network is C1.
So won't it be more simple if we club together R and C? And
You have to calculate a parallel impedance.
so what?
R1 C1, R2 C2, yes, we can do that. It can also be done that way. A little bit more calculation. Here there is no calculation, as you will see. This is the B network. For the B network, you can see that Y11 is S C1 plus C3. B network is S C1 plus C3. Y22 is equal to S, yes, I made a mistake here. This is C2. SC2 plus C3, and Y12,
Negative or S.
Y21 is equal to minus SC3. Alright, this is the Y parameter of this network. No calculation, is by inspection. What about the other network? The other network is R1, V1A, I1A, KV1, R2, this is V2, and this is I2A, alright. And you can see that all that I write is I1A equal to V1A divided by R1, and I2A is equal to V2 divided by R2 plus KV1, and the Y parameters are obvious. What is Y11? 1 by R1, Y12 0, Y21 K, and Y22 equals to 1 by R2. And because both of them are 3 terminal, you can simply add the Y parameters. Alright, I did not have to calculate the parallel combination of R1 and C1 or R2 and C2. I did not have to write, I had to write 2 node equations, but
Non-reciprocal.
this is non-reciprocal, yes, the BJT is non-reciprocal. Okay, is it active, BJT?
Yes.
Yes, it is active. The activity, however, is not obvious here. Activity will be clear if you write V1 I1 plus V2 I2. You shall see that it can be less than 0. It is possible to make it less than 0. Alright, so this network is active, and can a transistor be passive? Can a transistor be passive? Okay, last question of the day, number 7. Was there any problem in the 5th one? Number 7 gives an op-amp circuit, a practical op-amp circuit for an NIC, negative impedance converter, and the circuit is like this. Let me draw this, and the analysis would be extremely simple. This resistance is R sub B. It is not given in this figure. R sub B, and this is connected. Of course, the op-amp has a ground. This is the input port, and from here you have a resistance RA connected to the output. The second port is from here to ground. The question is, this op-amp, of course we have to assume that this is ideal. Okay, you have to show that this behaves as an NIC. The solution is extremely simple. what you have to do is assume this is the port V1 and this current is I1. You have to show that if port number 2 is terminated in, let us say, some impedance ZL, you have to show that V1 by I1, that is the input impedance, is, it can be equal to minus ZL or it can be proportional to minus ZL. The proportionality constant can be anything, okay, as long as the impedance is proportional to the negative of the terminating impedance, it is an NIC. So this voltage is V2 and this current is I2.
So the proportionality constant can be -1.
Proportionality constant, so long as it is positive, it will behave as an NIC, right sir? Proportionality constant can be negative. If the proportionality constant is negative for an NIC, then it is not an NIC, it is a positive impedance convergence, it's a PIC, PIC. Alright? Okay. Now, let us see how to calculate this. We invoke the idealness condition of an op-amp. One of the things that is obvious is V1 is equal to V2. Isn't that right? Because, again idealness, because the potential difference between these 2 points is 0. Virtual short, not ground. Why didn't you say ground? Because neither of these points are grounded. Is this clear? The ground is somewhere else. This is not ground because this is your port number 2. So we don't say virtual ground. Be careful about this terminology. In this situation it's a virtual short because the ideal op-amp has infinite amount of gain. Once again, the ideal op-amp cannot take a current and therefore the current I1 must flow here. Agree? The current I1 must flow here. When it comes here, the op-amp gives out some current, let us say I0, and therefore this current would be I1 plus I0. Alright, and this current after coming here, nothing can go to the op-amp and therefore this must be equal to I1 plus I0. Alright, so there are 2 things that are obvious, that is I2 should be equal to minus I1 plus I0, this current and this current. And the other thing that is obvious is that this drop across RA should be the same as the drop across RB, okay, which means that I1 RA should be equal to I1 plus I0 into RB. Is this correct? Pardon me? Why this should be so? You see, these 2 points are virtual short and therefore the drop across RA should be equal to drop across RB. But the drop across RB is I1 plus I0 multiplied by RB with this terminal positive. So there shall be a negative sign.
It's not clear why should I1 flow through RA?
Why should I1 flow through? Oh, because the op-amp is ideal. The input impedance at either port is infinity. If the impedance is infinity, it cannot take a current. It cannot, in the electronics language, sink a current. Alright, so the current is diverted through RA.
So but it can't flow through the virtual short.
No, because there is no connection. Current has to have a connection. The potential of 2 points may be the same, but there can be no current through that because there is no physical connection. Okay, any other question?
I2 is equal to I1 plus I0, not minus sign.
Pardon me?
Minus sign is not there. I2 is equal to I1 plus I0.
No, I1 plus I0 is flowing like this and I2 is flowing like this. They oppose each other and therefore one must be the negative of the other. Alright, convinced?
Why are they approximately short?
Why are they approximately short? Okay, the op-amp, ideal op-amp has an infinite gain. So to produce a finite output voltage, it requires 0 input voltage. 0 input voltage means voltage between this point and this point, and therefore they are short. They must be the same potential, ideal mind you, infinite gain. Okay, now any other? Okay, I1 RA equal to minus I1 plus I0 RB, and therefore V1 by I1, which is equal to Z input, would be equal to minus RA divided by RB into ZL. Alright? A simple manipulation of these two equations. I1 is equal to minus I1 R0 by RB and so on and so on.
So this doesn't come out to be negative, it comes out to be plus.
What comes out to be plus?
Does it come out to be PAC?
No? Where? You must not forget that V2 is equal to minus I2ZL. Alright? That's where I think you have made a mistake. So V1 by I1 is V2 by I1, and V2 is minus I2ZL. So it's minus I2ZL by I1, and we have already found out what I1 is. I0 does not come into the picture. It gets cancelled out. And you notice that if these two resistances are made equal, there is a negative impedance converter with a conversion constant of 1. What is the dimension of the conversion constant? Dimensionless. Okay. You also notice that by choosing RA and RB appropriately, one can multiply an impedance. Not only one makes it negative, but one can increase it or one can decrease it, the way one likes. And this circuit has lot of uses in active filters and in integrated
So how we
circuits.
got V1 by I1?
Pardon me?
So V1 by I1 is equal to negative RA by RB bundle.
Yeah, this is what it is.
How we got?
How? Okay.
Acha, yeah.
I1 is equal to
All right. It's very simple. Two equations. V2. This is V1. V2 and V1 are equal, and therefore V1 by I1 is the same as. Any other question? That's all for today.